starting material. Why? From the alcohols, aldehydes, ketones, all of these compounds, we can produce acids. Then acids have many importance in synthetic chemistry, I told you. So these alcohols, the aldehydes, ketones, all of them we can use for the synthesis of acids. Okay, first we are moving to the synthesis of acid from preparation of acids from primary alcohols and aldehydes. See, some reactions we studied in some chapters that here the reaction may be opposite. Suppose we are converting an aldehyde to some other compound, then that compound to aldehyde, that reaction we can use here. Suppose you are converting some compound to acid, so we can use this reaction here as a property of acid. Means acid we can convert into that particular compound. Got it? Same reaction we can use in two ways in different chapters. So if you are studying one equation properly, you can use the same equations in different chapters, different questions you can use that. Got it? Yes. So from primary alcohols and aldehydes, how can we prepare the acid? See, here I am taking a primary alcohol. What is primary alcohol? OH group is connected to one carbon. That carbon is connected to only one carbon. Other two groups are hydrogen. Okay, so what you have to do? The primary alcohols on oxidation. Okay, oxidation means it is addition of oxygen, we know, or removal of hydrogen. So as I told you, same thing when you are talking about oxidation reaction, we have to know the oxidizing agent is always means majority it will be potassium permanganate, KMnO4, or you can use potassium dichromate, that is K2Cr2O7. Okay, then one more thing is there, chromium trioxide, CrO3 in acidic condition. So these three are the important oxidizing agents we are using. That is called a John's reagent. Okay, so if you are taking a primary alcohol, if you are doing oxidation, they will directly convert into acid. See, here these two hydrogens are removed and one oxygen is added. That is called R. R group is not changing, carbon is not changing, this OH is also not changing. Then what is changing? These two hydrogen is removing and one oxygen is adding, RCOOH. Okay, primary alcohol. Another one example, see, here I am taking decanol. What is decanol? Because 10 carbon atoms are there, 8, 9, including this one, it will be 10. Then I am treating with the same oxidizing agent, I am converting into decanoic acid. Means one of the CH2OH group will convert into acid group. Okay, then carboxylic acids can also be synthesized from aldehydes using mild oxidizing agent. So what is the difference between strong and mild oxidizing agent? KMnO4, K2Cr2O7, they are means strong oxidizing agents. There are some mild oxidizing agent, means they are not that much strong. Okay, so using that mild oxidizing agents also we can prepare the carboxylic acids. Okay, see here we no need to know the mechanism, just the reaction is enough. So study the reaction properly, mechanism no need. Okay, now from the reaction, the preparation of acids from alkyl benzenes. What is alkyl benzenes? Benzene means we know this is benzene, right? What is alkyl benzene? We are substituting some alkyl group on the benzene. Suppose here I am writing CH3. It is an alkyl benzene, methyl benzene. And the common name is toluene. You know that one, right? You know toluene. Toluene is the common name for methyl benzene. Then you can add CH2, CH3, means ethyl group also we can add. It will be ethyl benzene. Propyl group we can add. That will be propyl benzene, like this one. Okay. So if you are taking any ASCO, commonly we can call it as alkyl benzene, means any alkyl group containing benzene. So you can convert the alkyl benzenes to acids. How? See, aromatic carboxylic acids can be, see, in the previous one we discussed about the aliphatic carboxylic acids only, right? Means the alcohols can be converted into acid by using strong oxidizing agent. That we are discussing about aliphatic carboxylic acid. Next one is aromatic carboxylic acid. They can be made by vigorously oxidizing alkyl benzenes with chromic acid or acidic or alkaline potassium permanganate. See, this is methyl benzene or toluene. Is reacting with potassium permanganate in basic condition. See, first you will get what? See here, this group, the CH3 group will first convert into COOK. What is K? This is not cook. It is COOK, potassium salt of this carboxylic acid. Okay, don't call it as cook. Okay, so this is the potassium salt of carboxylic acid. Okay, because why this potassium salt we are getting? We are using potassium hydroxide. If you are using sodium hydroxide, you will get sodium salt of carboxylic acid. Understood? So this sodium, potassium salt of carboxylic acid, you got it. Next, what you have to do? This one we have to convert into acid. What is the major replacement taking place here? This potassium is substituted by hydrogen. So what is the reagent you have to take? That is H3O plus acidic medium you have to take. Then they will take the H plus ion. Then the potassium will be replaced by hydrogen and produces benzoic acid. So this is a carboxylic acid, right? So you produced benzoic acid. Next one, if you are taking ethyl benzene, the same reaction is happening. Got it? Anyway, the alkyl benzenes can be converted into corresponding acid by treating with the potassium permanganate, and heating is also required. Okay, so this is the second preparation method. Next one, preparation from nitriles and amides. What is nitriles? Nitriles, I told you, the compounds containing CN groups are called nitriles, right? Yes. So, from nitriles and amides, what is amide? Amide means amide group is this one. CONH2 group is called amide group. CN group is called nitrile group. Got it? CN group is called nitrile group and CONH2 group is called amide group. Using these compounds, we can convert or we can prepare carboxylic acid. See, in presence of H plus ion or OH minus ion as a catalyst, nitriles can be hydrolyzed to amides and ultimately to acid. See this reaction. Here I am taking a nitrile compound. RCN means any group, R maybe any group. Suppose I am taking methyl, means methyl group. It will be CH3CN, right? So what you have to do, the first step is you are treating this one with, you can use H plus or OH minus. Okay, then what is the product? They will convert into RCONH2. What is RCONH2? This is amide. Got it? Then this amide again reaction with the same H plus or OH minus ion followed by heating. We will get carboxylic acid. The nitriles on reaction with the H plus or OH minus, they will convert into amide. That amide on heating, they will produce corresponding acid. Okay? Yes. Next, see here the first step is we are converting nitriles to amide, right? Next one, you can use directly, you can use amide. What you have to do? Take amide and heat it in presence of an acid or base. Okay, here if you are taking nitrile, you have to do 2 steps. If you are taking amide, you can do it in 1 step. That's all. Understood the difference, right? See here, 2-step process, it is a single step process. See another example, aromatic acids also we can produce by the same method. This is the amide, you are heating, means with as H plus or OH minus, you are getting the acid. And the byproduct is ammonia in case of amides. Okay, so this is the method of preparation from amides and nitriles. To stop the reaction at the amide, mild reaction conditions are applied. Suppose you don't want to produce acid, you have to produce amide only. Then what you have to do? Stop the reaction here. Here you can stop the reaction. Okay, by using a means mild reagents you can use, then you can stop the reaction. Okay, so if you are using nitrile, you have to do 2 steps. Means first step is we are converting the nitriles into amide. If you are doing with the amide directly, we can convert into acid. Okay, so that is the preparation from nitriles and amides. Next one is from Grignard reagent. What is a Grignard reagent? We know that, right? We discussed in many topics. We discussed about Grignard reagent. So what is Grignard reagent? R, Mg, X. R means any alkyl group and magnesium metal, X is the halogen atom, RMgX. So here the reagent is important. Grignard reagent all we know. What is Grignard reagent we know. But how will you convert this Grignard reagent to acid? That is the important thing. So here the reagent is carbon dioxide, dry ice. What is dry ice? What is dry ice? See, solid carbon dioxide is called dry ice. Solid carbon dioxide is called a dry ice. Okay, this is not the ice, the normal water means this is not normal H2O. This dry ice means solid carbon dioxide. Okay, so Grignard reagent react with carbon dioxide. See, here I am taking Grignard reagent, react with the carbon dioxide. See, the medium is also important. We are not doing this reaction in aqueous solvent or aqueous media. We are doing this reaction in dry ether medium. Dry ether. Dry means there is no water content. Pure ether without the water content means without any moisture content, we are using ether. So this Grignard reagent reaction with the carbon dioxide in dry ether medium, they will convert into carboxylic acid. Okay, so this is the preparation from Grignard reagent. Understood? So in case of the normal Grignard reagent, you have to take what is the reagent. Very, very important. I am telling you again and again. This reaction is very, very important. Because the reagent we are taking with the Grignard reagent is solid carbon dioxide. It is very important. Because we have to introduce COOH group, right? That's why we are taking the carbon dioxide. Okay? Yes. Next one, we are going to prepare this from acyl halides and anhydrides. Acyl halides and anhydrides. What do you mean by acyl halide? Acyl halides means RCOCl. This is called acyl halide. Right? Got it? So acyl chlorides on being hydrolyzed with water, they produce carboxylic acid. See, here I am taking acyl chloride. Acyl chloride means halide means instead of this chlorine, any X may be there. Bromine, fluorine, iodine, anyone. So I am starting with the acyl chloride. Okay, so what you have to do? See, these acid chlorides are reaction with the means water, means it is hydrolyzing. So what is the product you are getting? See, directly you are hydrolyzing, doing hydrolyzation reaction, you will get acid. Otherwise, what you can do? Take this one, do the hydrolysis and convert them into, see, its corresponding ion and convert into acid by reaction with the water, means hydrolysis. Okay, next one. Acid chlorides on being hydrolyzed with the aqueous base, they produce carboxylate ions, which then acidified produce the corresponding carboxylic acid, means this is the reaction. Okay, see another one. I am taking anhydride, that is benzoic anhydride. What is anhydride? We know, right? Yes. So this is benzoic anhydride. This anhydride means there is no water, right? So this benzoic anhydride on reaction with the water. Benzoic anhydride, we are reacting directly with the water. You are getting benzoic acid. Got it? Next one. Benzoic ethanoic anhydride. This one. On reaction with the water, we are getting benzoic acid and ethanoic acid. See, in these reaction, we are not only getting only one acid. Sometimes you will get mixture of acids, but the anhydride you are using for this reaction is different. You will get mixture of acid. Here you are getting taking benzoic anhydride. Means see, this is twice, right? Twice means the groups means both are same group. See, here you can see twice, same group. But here what you are doing, you are taking different groups, C6H5 groups and CH3 group. So you will get corresponding two acids. If you are taking same anhydride, means oxygen is connected to two anhydride group, you will get same acid. Otherwise, you will get mixture of acids. Okay? Yes. That is the preparation from acyl halides and anhydrides. It's clear, right? Yes. Next one is from esters. What is esters? Esters we know they have the formula RCOOH. COOR. This is ester. Esters have general formula RCOOR. Suppose I will write one example. CH3, COO, CH2, CH3. This is an ester, right? Yes. So from the ester, we can produce acid. How? How the esters are producing? When an acid is reacting with an alcohol, by the removal of water molecule, the ester is producing, right? See, I will tell you with an example. I am taking ethanoic acid, CH3COOH, plus I am taking methanol. What is methanol? OH, CH3. So what is esterification? Here we are removing water, right? See. So combine the remaining things. Then what is the product? CH3, C double bond O. No change here. This oxygen is still there. This hydrogen is removed. This OH group is also removed as water. Then this oxygen will connect to this CH3 group. See. This is the product you are getting, right? Yes. So this is the ester. From this ester, now we are going to produce the acid. This one. From here, we are going to produce this acid. How? The acids are converting into the esters by the removal of water molecule. Then the esters can be converted into acid and alcohol by adding water molecule. Same thing, opposite. Okay. So how will you produce? See, I am taking the same ester, CH3, CH2. No, it's okay. Another one, right? Yes. CH3, COO, CH3. Now I am going to do hydrolysis. What is hydrolysis? I am breaking this compound with water. So where you have to break? See, after COO board, put a line. Then add water. Water means they contains hydrogen and OH minus. Now it is H plus and OH minus, right? So simply we can say hydrogen and OH group. So what you have to do? CH3COO is there. So oxygen always negative, means they have high electronegativity. So H plus will move with oxygen. This side you can write H plus ion. Or no need to write this plus. You can write simply hydrogen is enough. No problem. In this side, along with CH3, you have to write OH. Okay. So what are the products? Then see, CH3, C double bond O is there. This OH plus CH3, OH. You got an acid and alcohol. Got it? Got it? This is the ester. See, normally ester is forming from the acid and alcohol by the removal of water molecule. If you want to produce acid from the alcohol or that means as ester, what you have to do? Do the opposite. The ester on hydrolysis. Hydrolysis means we are breaking the ester. We are breaking the compound with the water. Okay. So this is the esters on hydrolysis. Means we are breaking with the water, they will produce acid and alcohol. See, the same reaction we can use as a preparation for alcohol also, because here the other product is alcohol. Got it? Yes. So see one example. Here what you have to do, this is the reaction, right? So what you have to do, see, break here. After COO, break. Put hydrogen here, OH here. Then what is the product? You will get benzoic acid. Okay, same thing. Okay, then another one. If you're doing the next compound, what is the product you are getting for the next one? See, break here. After COO, break here. Then put hydrogen here, OH here. So you will get corresponding thing. But here you are reacting with the sodium hydroxide, right? Yes. Then what is the difference? If you are taking normal water, you will get the same thing as I told you. If you are taking sodium hydroxide, instead of water, you are taking sodium hydroxide. Then what you have to do? I will write CH3CO CH3. Instead of water, you are using sodium hydroxide. You are doing base hydrolysis. You are doing hydrolysis with, see, normal hydrolysis means we are breaking a compound with, lysis means breaking. We are breaking a compound with water. Hydro means water. Base hydrolysis means you are breaking a compound with a basic substance. That is called a base hydrolysis. So NaOH will convert into Na plus plus OH minus ions, right? The same thing. See, after COO, the bond will break here. Then what will happen? I told you, oxygen is always, they have a negative charge. Why? Because there is electronegative. So the positive ion will move here. Na plus will move here. OH group will move here. So what is the product? CH3 COONA plus CH3 OH. Got it? CH3 COONA plus CH3 OH. Okay, but here you didn't get the acid, right? Then what you have to do? This is the sodium salt of acid. Sodium salt of acid, you got it. This sodium salt of acid you can convert into corresponding acid. How will you convert? How will you convert the sodium salt of acid into acid? Do the hydrolysis again. H3O plus. Then the sodium will be removed and the hydrogen will replace the position. Then what is the product? CH3COO. Instead of sodium, you will get hydrogen there. Product. Okay. So this is the method of preparation from esters. Got it? Any doubt? Any doubt in this area? I will let me check the question answer session and then I can see if any doubts are there. I can see, right?